Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. This is problem number 3 from the last exam MLC written answer part from fall 2017. The XYZ Corporation Pension Plan provides the following benefits: an annual retirement benefit equal to 2% of the employee's average salary over the final 3 years prior to retirement for every year of service while a member of the plan. The normal retirement date is the employee's 65th birthday. The pension benefit is payable monthly for life. An actuarial reduction factor of 0.5% times the number of months that retirement precedes the employee's 65th birthday is applied to the benefit. You are given the following information regarding Caroline, a member of the plan. Caroline was born on January 1st, 1958 and became a member of the plan on January 1st, 1988. Salary information is as follows. In 2015, her salary was $90,000. In 2016, it was $92,000. In 2017, it was $95,000. Show that the accrued annual pension benefit for Caroline as of December 31, 2017 is $55,000 to the nearest 1,000. You should calculate the value to the nearest 1. The actuarial valuation is based on the following assumptions: a 6% annual effective rate of interest, salary growth of 2% per year with salary increases applied on January 1st of each year. There are no exits before retirement. Mortality after retirement follows the illustrative life table. A two-term Will House approximation is used for life annuities paid more frequently than annually. There is a 50% probability that Caroline will retire on January 1st, 2018. Otherwise, she will retire on her normal retirement date. Part B. Using the traditional unit credit funding method, calculate the actuarial accrued liability for Caroline as of December 31, 2017, and calculate the gain or loss to the plan if Caroline chooses to retire on her 60th birthday. Part C. Using the projected unit credit funding method, calculate the actuarial accrued liability for Caroline as of December 31, 2017, and calculate the gain or loss to the plan if Caroline chooses to retire on her 60th birthday. And here's the solution. Let us write S sub y for the salary in year y. The accrued annual pension benefit for Caroline as of December 31, 2017 is 0.02 times the number of years of service times the final average salary over the last 3 years of work, which is the average of the salary in 2015, 2016, and 2017, which is the average of $90,000, $92,000, and $95,000. Her number of years of service is 30, so we multiply 0.02 times 30 times the average of the 3 salaries, and we get exactly, 55,400. That's 55,000 to the nearest 1,000, and to the nearest dollar, or nearest 1, is 55,400. For traditional unit credit valuation, actuarial liability is calculated using salary as of the valuation date. Hence, actuarial liability is calculated as follows. If retiring on January 1st, 2018, there is a reduction for 5 years. She's retiring 5 years earlier than her normal retirement age. That 5 is multiplied by 12 because 12 months in a year times 0.5% reduction per each month of retiring before normal retirement age. So that's The reduction factor is 1 minus 0.005 times 12 times 5 times the benefit of 55,400, which is paid as a life annuity payable monthly starting at age 60 in case of early retirement at age 60. And then Woolhouse 2 term approximation for A double dot 60 upper 12 is A double dot 60 minus 11 over 24. And then from the illustrative life table, A double dot 60 is found to be 11.1454. So we plug those numbers in. 12 times 5 is 60, multiplied by 0.005 gives us 0.3. 1 minus 0.3 is 0.7, so it's 0.7 times 55,400 times 11.1454 for A double dot 60 from the table, minus 11 over 24, and that gives us 414,445.45. Now, if she retires on January 1st, 2023 at normal retirement age, there is no reduction, so the reduction factor is 1 minus 0, so really 1, times the annual benefit of 55,400 times A double dot 65 upper 12. That gives us the actuarial present value at the time of retirement of the benefits that she will receive. But because we're doing the valuation 5 years before that, we need to discount it at 6%. And the problem actually tells us that there are no exits before retirement. So this is just multiplied by the interest discount factor over 5 years. So it's accounting only for interest, not for probability of survival. And then we use the Woolhouse 2 term approximation. So this A double dot up 1265 becomes A double dot 65 minus 11 over 24, which is m minus 1 over 2m. That's what this is, where m in this case equals 12, but m is the frequency of the annuity, how often it's paid per year, or how many times it's paid per year. And then we find the A double dot 65 in the illustrated life table to be 9.8969. So we plug this all in, and we get approximately 390,738.75. We are told that there's 50% chance of her retiring in 2018 and 50% chance of retiring in 2023. So the expected value of the accrued liability or actuarial liability or accrued actuarial liability is the average of the two. Accrued liabilities as of 2018, the first one, and as of 2023. Now, of course, it's the calculation is done now. It's not done upon retirement, but still, that's the liability established for retirement at those times. So that average is 402,599.60. And if she chooses to retire early, then the gain is this liability minus the actual liability if she retires early, which is 414,445.45. That's actually a loss. The pension plan suffers a loss because she retires at the time that produces a higher value of benefits to her than the average calculated above. It's a loss of 11,852.85. For Part C, under projected unit credit, projected salaries are used for valuation. Now, if she retires on January 1st, 2018, accrued benefit is 55,400, same as before because there's no salaries to project. She is retiring at the time. And so the accrued benefit is 55,400. If retiring on January 1st, 2023, projected annual benefit will be different because her salary will go up. Now, a very important observation here is that we don't include those future years of service that she hasn't done yet. because if we were to do this type of valuation, then we would have to include the future normal costs and normal contributions in the valuation. We don't do that. We don't do this in the unit credit methods. It's what's accrued, earned up to date. And there's a credit for every year served until now. That's roughly the idea. However, projected stands for the fact that her salary is projected till retirement. So the average salary will be over last 3 years before retiring in January 1st, 2023. So it would be salary for the year 2020, 2021, and 2022. And those salaries, well, I have them here in opposite order when I wrote the actual amounts of salaries. So 95,000 times 1.02 to the fifth is actually the salary in the last year, 2022. 95,000 times 1.02 to the fourth is the salary in 2021. 95,000 times 1.02 cubed is the salary in 2020. Let's all this divided by 3 for the average final salary, multiplied by 30 years of service, because we don't look at the future years of service. We only project the salaries, times 0.02, 2% credit for each year served. And this ends up being 61,706.70 approximately. Now, if she retires on January 1st, 2018, the calculation of accrued liability is the same as it was done before, because there's no projection in the salaries. So this ends up being the same accrued actuarial liability as calculated under traditional unit credit. But if retiring on January 1st, 2023, we have to use those projected values of benefits. So the annual benefit expected will be 61,706. The value of all the benefits and retirement will be that 61,706.70 times A double dot upper 1265. And there is no reduction. 1 minus is just 1, so there's no reduction for early retirement because she's retiring at normal retirement age. But this value is calculated at 2023. To bring it to today's valuation, we need to discount it over 5 years. And again, we only discount for interest because we are told there are no exits prior to retirement. Normally, you would have to account for probability of survival as well. Then we use the Woolhouse two-term formula to write A double dot 65 up to 12 to be A double dot 65 minus 11 over 24. We look up A double dot 65 in the illustrative life table, and it's 9.8969. So we plug in all the numbers and we get the accrued liability for retirement in 2023 to be 435,220.19. And then the expected value of accrued liability, well, it's effectively the average of the two, because each has probability of 1/2. Now remember that both values are established as of the valuation date, so there is no need to worry, oh, okay, are we calculating numbers from different times? No, both values are as of the valuation date. They just represent valuation for different retirement ages. So given these probabilities, we just take the average of the two numbers and ends up being 424,832.32. Now notice this is more than what we had before, and the actually only reason that it's more is because we project the salaries. So the accrued liability for retirement at normal retirement age in 2023 is significantly higher. Well, significantly, it's higher. Visibly higher, let's put it this way. Well, it's about 10%, so it's significant actually. So we end up with a bigger value of the average of the two. And if she chooses to retire early, now the difference between this accrued liability we just calculated and accrued liability for retirement in 2018 is 424,832.32 minus 414,445.45, and that's 10,387.87. This is a gain to the plan because, in this case, retiring early means that the liability turns out to be smaller than the expected value of the liability. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.